Hello everyone. So far, we've spoken about acids and bases. We just touched upon salts. Today, we'll understand salts better and we'll finish up this chapter. So first and foremost, a salt is formed when an acid neutralizes a base. Alright? Now, this is very generic. It could also be like we saw many other cases. But when an acid reacts with a base, you get a salt. That is how we usually take it. Now, depending on which acid or which base it came from, you can classify salts into families. Alright? So say same acid, you have a family, or the same base, again you have a family. What do I mean by this? Let's say HCl is my acid. You could have NaCl, KCl, AlCl3, ZnCl2, we did aluminium. You could have PbCl2 and so many. So over here, if you see, the positive ion is different, the cation, but the anions are all the same. It all comes from hydrochloric acid. It's the chloride ion. So this is a family of chloride salts. In the same way, if I say it's the same base, let's think about sodium hydroxide, right? We can get sodium chloride, we can get sodium sulfate, we can get sodium phosphate, we can get sodium nitrate, and so on. Alright? So here if you notice, the cations are the same. It's all sodium, it all comes from sodium hydroxide. But the anions are different. Chloride comes from hydrochloric acid, sulfate comes from sulfuric acid, phosphate comes from phosphoric acid, nitrate comes from nitric acid, and so on. So these are a family sodium salts. So in general, a family of salts has at least one ion that is common throughout the family. Alright, so it can either be an acidic family or a basic family, it doesn't matter, but they can be classified as a family. Please note, HCl itself is not a part of this family because HCl is an acid. We are talking about chloride salts, or they have to be salts in general. The same way sodium hydroxide is not a sodium salt, it is a base. So please don't write NaOH as an example for a family of sodium salts because that is not how it works. Just saying. So what about the pH of salts? Well, like I said when we were discussing pH, sodium chloride, NaCl, is neutral. pH is 7. Why is that? Can someone think about a possible answer why that might be so? Well, sodium chloride comes from, or let me just say, comes from NaOH plus HCl. Now if you go back and think, sodium hydroxide is a strong base. Hydrochloric acid is a strong acid. So when you dissolve NaCl in water, NaCl in water will give you Na plus Cl minus. These ions are of somewhat the same strength, right? So even if they recombine with water, if they undergo hydrolysis, it doesn't happen all the time. It doesn't happen with very strong salts. But even if it does undergo hydrolysis, you will get an equal quantity of OH minus and H plus ions. So that way, the pH will continue to be neutral because the concentration of H plus and OH minus with respect to each other is not going to change. But what about, say, AlCl3? Now we know AlCl3 comes from AlOH thrice aluminum hydroxide plus HCl, right? So when you dissolve aluminum hydroxide in water, think of these two compounds forming. Clearly, aluminum hydroxide is not a very strong electrolyte. It is not as strong as, say, sodium hydroxide. So the number of H plus ions are greater than the number of OH minus ions when you dissolve aluminum chloride in water. So obviously, if H plus is higher, pH is less than 7. So AlCl3 is acidic. The same way, think about Na2CO3, for example. This comes from NaOH and H2CO3. Now we know sodium carbonate is not a very strong acid. So the concentration of OH minus ions in solution is higher than the concentration of H plus ions. Therefore, the pH will always be greater than 7. So a solution of sodium carbonate is mildly basic, whereas the solution of aluminum chloride is mildly acidic. Now, if it's a strong acid and a strong base like sodium chloride, it is always neutral. All right. Now, before we continue, I want to speak about another concept called dilution. Okay. So when you have a certain amount of H plus ions, say 100 H plus ions in solution, and that solution has, say, 1000 water molecules. And this is just an example, all right? Now, if I were to add another 1000 water molecules, say add 1000 water molecules, what happens? You have 100 H plus per 2000 water molecules. So the concentration of this solution is 50% or half the concentration of this solution. All right. So when you add water to a solution, you are diluting the solution. That process is called dilution. The same way, if you start evaporating the water, if I have 100 H plus ions per 1000 water molecules and I remove 500 of them, then I will have 100 H plus ions per 500 H2O molecules, which is as good as saying I have 200 H plus ions per 1000 water molecules. Right, so now the concentration is doubling. This is solvent removal. Or you can also think of it as addition of 100 H plus ions per 1000 water molecules. So this process is called concentration. All right. Now the removal of a solvent or the addition of a solute is concentration. And the addition of a solvent or the removal of a solute is called dilution. These are things you need to remember. A side note, dilution of an acid is always an exothermic reaction or even a base. So if you have concentrated sulfuric acid and you add water to it, it can spurt. It is extremely hot. It can cause the glass to break or it can cause the acid to jump. So it is not recommended to do that. Instead, it is safer to take water and add acid to it slowly. That's just something I wanted to let you know. So now that we covered dilution and concentration, how do you get common salt. Now, when you say salt, the first thing that anyone might remember is sodium chloride. So how do you get common salt? Common salt is found in two sources. One is the sea or ocean. The second one is rocks. So salt from the sea is called sea salt, and salt from rocks is called rock salt. Salt from rocks, it is mined, right? Just like you mine coal or any other mineral, you can mine it. And salt rocks are usually brown or pink in color, and a lot of them are found in Sindh. So you have salt pans. What used to be an ocean in thousands, millions of years ago, when the ocean dried out, the salt remained and it became like a mineral. So that's where you get rock salt. Sea salt, on the other hand, is when you take sea water and you evaporate it. So sea salt is obtained by evaporation and then purification. So in the ocean, you have many other salts. So when you evaporate ocean water, you get many of them. You have to purify it and you have to separate sodium chloride from it. So this is what happened in the famous Dandi March, where Mahatma Gandhi walked from Sabarmati to Dandi. He evaporated water from the ocean and prepared salt. So what is so special about common salt? Common salt is used in the manufacture of various significant chemicals. All right. So the first most important chemical that you can make from plain sodium chloride, table salt, is sodium hydroxide. Yes, the strong base we've been talking about, sodium hydroxide, that comes from sodium chloride. How do you do it? You do it by what is called the Chlor-Alkali process. Okay, it is an established industrial process where you take an electrolytic cell. Let me draw it out for you. You have two electrodes separated by a membrane. A semi-permeable membrane actually. Enclosed in a tank with two vents. All right. So when you pass electricity through this is the positive side of the battery, the negative side of the battery. The positive side is called anode. The negative side is called cathode. The whole thing is in water. All right. Okay. So this membrane doesn't allow the passage of gases. So what happens when you pass current? What happens? What are you feeding in? In here, you input brine. Brine is concentrated salt water. Okay. So when you input sodium chloride, what happens? At the anode, the chloride ions, which are negatively charged, release their electrons and go out as chlorine gas. Okay. And at the cathode, on the negative side, you have the H plus ions, which pick up electrons and they go out as H2 gas. Okay. So what is remaining here? Na plus is remaining here, and these Na plus ions can go through the membrane to form NaOH, because H plus is going out from water. OH minus is remaining. So Na plus plus OH minus can be taken out as sodium hydroxide solution. Okay. So this process is called the Chlor-Alkali process. Chlor because you have chlorine coming out, alkali because you have sodium hydroxide coming out. This is a very simple explanation for it. If you want the complete chemical equation, it's more like sodium chloride plus water gives you sodium hydroxide plus chlorine gas plus hydrogen gas. This is an electrolysis reaction. So how do you balance this? You have half chlorine, half hydrogen. So that's how you can balance this. So why is this reaction of any significance? Well, let's look at the products we get from this. The products, which are these, sodium hydroxide is very important. Sodium hydroxide is used in a variety of chemicals. It is used in industries, experiments, research, many other places. Okay, it has a variety of uses. Chlorine gas is used in the manufacture of bleach, in the manufacture of soaps, in paper, etc. It has hundreds of applications. Chlorine gas is used in the manufacture of bleach. It is used in various kinds of hydrocarbon industries. Plastic manufacture, for example, your PVC, all those things. It is used as disinfectant and so on. It's used in chlorinating swimming pools. There are hundreds of it. It is also used in research industries and all that. The hydrogen gas that is produced, the hydrogen that comes out over here, is also very useful because hydrogen can be directly used as a fuel for fuel cells, where hydrogen can be converted to electricity. It is also used in hydrogenation of oils, the preparation of margarine. It can be used in ammonia production, the Haber-Bosch process, and in the manufacture of fertilizers. So all the products that you get from this reaction are of significant importance. Okay? So we spoke about bleach. How do you make bleaching powder? Bleaching powder is another of those important chemicals that you can make from sodium chloride. So let's speak about bleaching powder. Bleaching powder is formed when you take calcium hydroxide and you pass the chlorine gas that you got from the Chlor-Alkali process. That will give you CaOCl2. This is calcium oxychloride. And of course you get water alongside. But this calcium oxychloride is the active ingredient in bleaching powder. Bleaching powder has many other things, many impurities and stuff. But the most active ingredient is calcium oxychloride. And calcium oxychloride is used in bleaching industry. So if you see those nice white cotton cloths and linen and textile, that whiteness is because of bleach, because raw cotton is yellowish to brownish in color, raw paper is brownish in color, so paper, textile, and so many other industries. Okay, it is also used in laundry for very white clothes, hospital sheets, things like that. Bleaching powder is used. It is also used as an oxidizing agent in chemical industries. And it is also used to purify and disinfect drinking water. It's used in water treatment. So bleaching powder is one of those important chemicals that you can get from the Chlor-Alkali process, which is directly from sodium chloride, salt. What else can you get? You can get baking soda. Now baking soda is formed when you take sodium chloride, you mix it with water and you carbonate it, and you use ammonia as well. You get NH4Cl, which is ammonium chloride, plus NaHCO3. Let me just write that in the next line. So NaHCO3 is sodium hydrogen carbonate, also known as sodium bicarbonate. Now, what is it good for? It is used in the process of baking. Okay? Its uses, let me just change the color here so that we know what we're talking about. One, in the formation of baking powder, in making baking powder. Now please note, baking soda and baking powder are different things. Baking powder is a mixture of an acid like citric acid and baking soda. So in the presence of acid, when you mix it with water and you make your dough, carbon dioxide gas is released, which helps in making the dough more fluffy. Leavening of the dough, that's what it's called. All right. The next one, it is used in antacids. Like I said, NaHCO3, when you it has a pH that is above 7 because sodium hydroxide is a strong base. So it can help in reducing the acidity in the stomach. It is used in the making of antacids, which is sold as medicine. The third one, it is used in soda acid fire extinguishers. So when you mix a hydrogen carbonate with an acid, I said carbon dioxide gas and water are produced. So carbon dioxide gas is used in putting out fires because it moves oxygen away from the flame, and if oxygen is not there, fire is put out. Okay? But what happens when you heat sodium hydrogen carbonate? So NaHCO3, when you heat it, you get Na2CO3 plus H2O plus CO2. So even during baking, you get carbon dioxide. So that helps in making your bread fluffy. Let's just balance this quickly. Okay. So sodium hydrogen carbonate, these are the uses. The next compound that you can get comes from here. This is sodium carbonate. All right. The next compound we'll be speaking about is washing soda. Washing soda is Na2CO3 plus 10 water molecules. You will get Na2CO3.10H2O. Now please note, this does not mean that your sodium carbonate is wet. No, it's not a solution. This is a crystal. Okay, it's called recrystallization. This is also just a powder. It is not liquid. So this is also very important. It is used in various places. Firstly, it is used in the manufacture of glass, soap, paper, many other places. It is used in the manufacture of sodium compounds like borax. It is used as a cleaning agent in domestic use. Also, it is used in removing permanent hardness in water. Now, water is considered hard if it has salts of magnesium or other elements that prevent soap from working well, that leave stains when you're cooking, that cause scaling in boilers, those kind of problems. So if you treat it with washing soda, those things are removed. All right. But let's go back to the concept behind this. Now these crystals, when you say there is water in the crystal, it doesn't mean the crystal is wet. It doesn't mean it's a solution. It just means that the crystal has water in it. A classic example would be copper sulfate, right? If you have some copper sulfate, take it in a test tube and heat it. All right, heat it on a flame. When you heat it, it converts, or you can say that you get a nice white solid there. Now this is also CuSO4, whereas this is also CuSO4 with water. All right. Copper sulfate is blue in color when it is hydrated. I'm not sure about the two, so I will just say XH2O. Copper sulfate dehydrated is white in color. It is the same compound, but removing the water changes the crystal structure and it changes the color it is. Okay. Another example is, another example that we would like to speak about is plaster of Paris. All right. Now plaster of Paris is gypsum. Gypsum is calcium sulfate. Please note, this is calcium. Okay, this is 5H2O, just so that you know. Calcium and copper, they're two different compounds. This is copper sulfate. This is calcium sulfate. Calcium sulfate dot 2H2O is gypsum. It's a mineral of calcium. All right. When you heat this, it loses water and you get CaSO4 dot half H2O. This is called calcium sulfate hemihydrate. Now hemi is half, so you have half a water molecule per molecule of calcium sulfate. Now this is commonly called plaster of Paris. A plaster of Paris is used in dental casts. It is used in plastering hands or legs whenever a bone is broken to help in better growth. It is also used as a construction material and things like that. Now please note that you can't store plaster of Paris in the open because it will absorb water from air and convert to gypsum. Gypsum cannot be used as plaster of Paris. So you have to store it dry. Okay? It was called plaster of Paris because gypsum was found in Paris and upon heating they were able to convert it into this. That's all. There's nothing special about it. There's no big story. But plaster of Paris is a partially hydrated salt. You can completely dehydrate, completely hydrate, depending on what your application is. The physical appearance may change, but chemically it is still the same thing. Please note that water in the crystal doesn't mean the crystal is wet. It just means that it is hydrated. Okay. So with this, we touched upon the uses of salts. We touched upon the uses of various compounds that are formed from common salt. This is it for this chapter. If you have any questions or comments or doubts, please leave them in the comment section below. I have a link for the formation of sodium hydroxide, the Chlor-Alkali process. That's the only link under this. Please make sure to watch it. It's a good video. All right. Thank you very much.